So here we are on Section 4, Week 2, Video 2. This will be a Friday. So we have one class and a second class, and then a quiz on the second. I'll get more details on the quiz. The quiz structure will be the same as all the others, just when the timing will be. And it looks like, as far as the player is concerned, we have the cart animation script. We have this cart player animation script. We already went over keyboard input. And we spent a lot of time with arcade cart, which is a massive script dealing mostly with all the physics of moving the cart. And just double check them. Yeah, just a bunch of colliders underneath. Oh, we went over this arcade engine audio, just an audio manager. It's kind of interesting. We got fluctuating sound using the sine wave. Fluctuating volume, I should say. We have a lot of environmental pieces we should probably look at. So let me just continue with the cart. Let's look at cart animation. So the actual like animator of the car. Now, remember, there's like a player animator and a cart animator. So let me just see what was sitting out here. We have a cart controller. So it wants to know about the controller up here. It wants to know about all the wheels, the transforms and the colliders of the wheels, max steering angle, steering animation. Okay. So it looks like we have a class inheriting from model behavior. It's a component script. So this is interesting. Default execution order 100. So I wonder if there's documentation on this, but basically there's like a script execution order, and so like normally the way the order of like the awake functions and the start method, I should say methods and update methods, it's like from top to bottom. We move through all these game objects, and that's when we process all their mono behavior methods. But there is a way to like override it if you need to. Like there's this execution order. Don't really mess around with it that much, because if you definitely need stuff to be like at the end, there's late update. And I even think let me double check. I don't think there's an early update. I had like those links to tile map, conditional compilation. No, but it was close. It was like somewhere within that documentation, close to this one. Okay, here we go. Cool. Looking for the order of execution. Here we go. So initialization, awake, unable, reset start. We have fixed update for physics. We have update, and we have late update. We don't have early update. Okay. So anyway, you can like mess with the order that the scripts are executed, but rarely do you need to do this. But that's what that little attribute is doing. Script execution order. So here you're stating like add scripts to the custom order and dragged into reorder. So like the more negative a number, the more the earlier it gets executed before others. So you can see here's like default time. So anything that's in default time gets processed in that big like update loop, and then stuff that happens beforehand, the event system for user input, all like the UI stuff Cinema Brain is later for whatever reason. But anyway, you can like specify an ordering of when things are done. And so this one is late, is like 100. So for some reason they want the animator to process after everything else. But I would say if you do want it to go after everything, yeah, I mean they're putting it in late update. They want like at the end of late update. They want to make sure everything is done, even if other scripts are using late update, and this is then done all at the end. Okay, so that's what this little thing is doing up here. So serializable public class wheel. All right, so we have another class here. It's not inheriting from anything. It's just a class called wheel. It's serializable so that we're going to be able to see it in the inspector. And for each wheel class, it's going to have a public transform, public wheel collider, quaternion for its rotation, and some quick methods here. Setup, store default rotation. Okay. So at some point we must create. Yeah, okay, we're creating down here. So all right, here we want to know about the arcade cart script. Some steering dampening. So appearance of steering compared to the higher the number, the less dampening. Okay. So like how late after user input do you want the animation to start to show to the user? And then we have our wheels, public wheel, wheel, so which we defined up here, and they're serializable, and that's why we can actually see the details of them right here. Now, we have a start method, and it looks like all 4 of these need to go through setup. So we better, if we don't tell in the inspector, if we don't like connect up what these wheels are, looks like we'd probably get an error. So let's see what their setup is. So grab this wheel transform here and grab its local rotation and set it equal to this field, this private member, it's a quaternion. So if this wasn't set, like out here, if somebody would go through and set all 4 of these, then this setup would happen on start, and we would get an error because we didn't have a transform to reference, even though we're saying reference it. And then in the fixed update, so in addition to all that fixed update stuff that's going on in the arcade cart, we're going to say take the float, move towards. So okay, take our smooth steering input. Which we define. No, I think that's weird. It's not okay, here it is. It's a float. It's not defined. Should be defined somewhere in here. So it's just 0. All right. So in the first frame, it's going to be 0 because that's what float defaults to when you don't do anything. So this would be 0 to start off with, but we're going to move towards this 0 to cart controller input, turn input. Okay, so it's when the user is pressing left and right, this number is going to range from like -1, 0 is nothing, to 1. And so, and then how far are we going to move towards it? So it's our steering animation dampening, which is defaulting to 10 plus times the little amount of time. So this is like a little fraction of a second, right? So in fixed update, maybe it's like 0.1 or 0.2. I believe it's 0.2, but 0.2 of a second per fixed update loop. Let me just double check that. So if we go into physics, no, it would be like there must be like a time setting somewhere. Time. Yeah, fixed time step 0.02. We're going at normal time scale, 100% of time. You slow this down for bullet time, or you put it to 0 if you're in a pause. And we do it's 0.02. Okay, it's very small. So basically 2 1/100th of a second. Every 2/100ths of a second, we're doing a fixed update loop. So this is a very small number every time, multiplied by 10, which is 0.02 times 10, so 0.2. So move towards. So the max amount that we can move towards it. So where are we currently? Where's our target? Where are we moving towards? And how much? What's the max amount that we can move? So this starts off at 0. This here just depends when the user is pressing anything. Let's just say they're pressing to the right. So it's 1. And we're only going to move towards it 0.2 every fixed update frame. So that's how we're getting like a smooth. It's not like going from 0 to 1 like right away. It's doing, as long as the user is like holding down the right, like this becomes like a 0.2, and then the next frame it'd be like a 0.4, and the next frame like a 0.6, then a 0.8, then a 1, and then it's a 1 to 1. Like it's smoothed up to 1 over like 5-6 frames or whatever that was. And then if the user like releases the turn input, it becomes 0, but our smooth steering was at 1, and it's going to take like 5-6 frames to go back to 0. So that's what this is doing. It's smoothing the transition so that it's not like instant tire turns. You know, over 5-6 frames, the tire will turn. All right, get our max steering angle times the smoothing agent. That's how much our rotation angle is going to be. And then go into these wheel colliders. In the steering angle in degrees, always around the local y. So always a local y, because we found that that's what we care about with turning. Remember, y is up, and the local y, whatever your orientation is, in this case, we're perfectly aligned with up, global. But remember, we want to rotate along the y. We only care about this when we're steering. So that's why it's just a float, because we only care about the rotation. In this, wheel collider has already been set up to deal with angles and degrees around the local y-axis, and it's just coming from the smoothing. All right, so update the position rotation from wheel collider. So it's kind of interesting that this says animation, but this is actually changing the steer angle of the actual physics collider. So this is actually impacting our physics too. So the name of the script might be a little, not 100% reliable there. But we go through all 4 of these with update wheel from collider. So the wheel comes in this wheel class, and it says, okay, go into your class, go get a reference to the wheel collider, get the world pose. So this must be a method available on the wheel collider. So this is interesting. So it returns void, right? So it's not returning anything because it's actually returning 2 things. If you notice, both of the input parameters are tagged with out. So they're editable, they're being written to, and then you have access to them. They come back out. So there's 2 return types, basically. I mean, they could have just wrapped this up and like returned like an object of a class that has these 2 things as properties, but whatever. This is another interesting way to say, like, another interesting use case. This method returns void, but 2 of its input parameters are actually passing out data. Get world pose. So get its position, its rotation, and then we're setting the position rotation to our transform. So whatever the collider is doing its calculations in the fixed update, and it looks like even after we mess around with it, we tell the wheel collider, hey, we're going to update your steer angle every fixed update loop. And then what this is doing down here is, hey, whatever after we adjust that, get your world pose. And we're going to update our transform that connects to it. We're going to update its position rotation. So this is actually manipulating the physics colliders and the transform a bit on the wheels. So this is what, like a wheel manager. But okay, so and then that was in fixed update. And then in late update, we're correcting them again. We're doing the same thing again. Okay. So I'm guessing this is like an extra safety precaution. Maybe the physics gets a little wonky because they're like manually changing quite a bit of things, and maybe if they update it yet again in late update, kind of like resecures it if some like weirdness starts to come in during update or late update. Anyway, this is more like a wheel collider manager than an animation manager. But in any case, more physics. Um, and all it's really doing is it's smoothing out. I guess you could. It's not the cart animator. It's like the wheel animator mixed with transform updater because it is like rotating the wheels, and that is a form of animation. So I could see this as like wheel animation in like physics manager or something. But interesting, and they're really manually controlling everything to get like a custom look and feel. And so then there's the cart player animator, and let's see what we're doing here. So it wants to know about the actual player animator and the arcade cart collider controller. And there's two strings here, parameters. This must be they're passing them into the animator, steering and grounded. So we'll take a quick look at the player animator just to remember what's happening. This one seems to be more dealing with animation. So yeah, the animator on the player has steering and grounded. And if you remember in driving, yeah, it's a blend tree. So if you take a look at it, based on how much are they turning, we'll change the turning animation of the player. And you can see it down here. That's all within this driving state. So let's see, we have some integers, steer hash, ground hash. Hash is a pretty specific term in computer science. Let me see how they're using it. Steering smoother. So on awake. So assert is not null. This is something new. So the assert class contains assertion methods for setting invariants in the code. So you could say that this is a check, and I'm not sure what it would do. Let me see if it gives off a warning or like an error, and it stops us in our track. So if I went to here, and it says, what does it want to know? The cart and the player animator. So if I just like wipe this out, you just set it to none. Let me just see what would happen. Assertion, yeah, assertion. So we get an error, we wouldn't be able to play. So this would crash. Assertion exception, no player animator found. So let me go back and set that back to the animator. Okay. So we have this assert class. So I mean, we've seen previously that for like if these are required, you could say at the top here note that like require component of type, player animator, animator and arcade cart, which that would work for arcade cart because if it would say require component, it would check on the same game object, which the arcade cart is. But the animator is on a different game object, so I guess you would have to use the assert here because you couldn't use like require component for this. So this is like a class for like kicking off your own exceptions, doing your checks and doing your own section. So this method is not null. So what you say is you pass in the name of the variable, and here's it's a property in this case, and say this can't be null. You check if it's null. If it's null, we're going to kick off an exception and basically, stop the program from working. And then pass this message: no arcade cart found. In this case, no player animator found. So this actually went through as the error message. Okay. So it's different than required component. Required component would have worked on this one because it's on the same game object, but not on this one. So it looks like they did this assert. By hash, do you mean the same kind of hashing? That's what I'm thinking. But let me see what it actually means. I'm not really sure right now. So animator string to hash generates a parameter ID from a string. So yeah, it is hashing, but why are they hashing? So we're going to pass in our steering param, which is this here, just a string of steering. It's going to generate a hash code for it, a parameter ID, and we're going to store it here. So it's an integer, and here are the two integers. I'll explain what that is. Let me try to figure out what's the point of it. But basically, it's like creating unique IDs for each of these. And yeah, you're right. Hashing can be used for passwords, but I'll explain hashing in regards to other use cases that it's used a lot on servers and cloud computing. But I'm going to show you an example of how it's used with dictionaries. But in any case, I don't know why they need to do that right now, and let me just keep going on and try to figure it out. So in update, steering smoother, so float steering smoother equals mathf, math library for floats, lerping. We're going to lerp from steering, whatever steering smoother is, 0 by default, to our input. Okay, so it's doing what the other cart animator was doing. So it defaults to 0, but whenever the user presses this, just to say they press it to the right and this is a 1, we're going to smooth delta time times 5. So delta time will be a small little number again, multiplied by 5. It means we're basically slowly moving. So this is the difference of lerp or move towards. The other one was move towards. And lerping is goes from 0 to 1. We're starting at A, we want to go to B. What's our progress of our journey is T, from 0 to 1, from 0% to 100%. And move towards is saying, well, here's even if it's math f dot move towards, here's an initial float, here's a target float. So it's kind of like A and B. But then it's like how much? What's the max amount that we can move towards B? So they both kind of do similar things, but one is saying what's the percentage of the journey that we are at, and I'll tell you where we are in our journey. And the other one, move towards, is like, I want you to move towards this location or this rotation or this float by this much, this amount of value. Tell me where I'm at with that. Very similar, but they're used for different use cases. But the other one was using move towards, and this one's using lerp for whatever reason. Player animator. So we're going to grab our animator, we're going to set the float, and it's going to be this float here, steering. And that's the name of it, but we're passing in an ID. And I think this is one of those cases where they're trying to be fancy, but it's interesting. I need to explain some stuff with this. Basically, it's saying set float. Either notice you pass in the ID of the parameter. So these parameters, you can grab them by their ID, a unique ID that's generated for them that's guaranteed to be unique, owning only that number will only be owned by that parameter. Or you can pass in a string for the name. I'm used to passing in the string, which they have the strings right here. So anyway, you can pass in the name or the ID. And then you pass in the value that you're setting it to. And the same with the set bool, we're going to set that ground param. And if the cart ground percent is greater than 0.5, if at least 2 wheels are on the ground, then if more than 2 wheels are above the ground, then we consider that the cart is airborne. Okay. So if ground percent is greater than or equal to 0.5, this will be set to true. Otherwise, false. So that's how we're actually. So this, I don't know how the cart here. Oh, this cart doesn't even have parameters. It's just why it just idles. It just does that like, blah, 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 blah. And we rotate the tires with that cart animator script. This one, animator actually has parameters and can switch states. So this one is more of an animator script. So let's go back to the string to hash. So this is the animator saying, okay, animator, I'm going to call a method on you called string to hash. And what it means is I'm going to tell you the name of your parameter, and you're going to give me the unique ID for it. The unique ID will be an integer. And I can remember that integer, and it's a unique ID, and I can pass that in down here for when I want to call it. I mean, at the end of the day, I still needed to know the names of the parameters. Maybe it's more lightweight. Maybe I'm thinking that a string takes up more memory than an integer, because each of these characters actually requires a certain amount of memory, so it's variable based on the size of it. But once you get past a few characters, you're passing the size of an int. But maybe because it's done in the update, I don't know. I think they're just showing off new stuff. So anyway, string to hash, generate a unique ID, and they're using a unique ID to call it a parameter. But the animator is the one that's generating the hash code. Hashing is used a lot, but the name of it is a unique ID. So whenever you see those, like, what is it, like the bit.ly or like short, I forgot the name of them, these URL shorteners, there seems to be a bunch of these. But whenever you see like a really shortened URL, that's a unique ID, right? It's a bunch of like hex code, but it's really shortened down than this super long hyperlink. And how did they get this super long hyperlink, which is essentially a string? How do they convert it down to something that looks better? Basically, it's showing less characters. So that's called hashing. It's like, take a string and give me a unique ID. Sometimes they're integers, and when you see like a mixture of characters and numbers, that's usually like hexadecimal. And so basically you can store more amount of numbers per digit because it's not base 10. So an integer is a base 10 digit, and hexadecimal number would be base 16. So you could like squeeze more numbers in per character, basically. And so if you're trying to shorten a string, you want to use hexadecimal format. Anyway, there's like an algorithm that you can use that would be like, for every single type of unique string, I could give you a unique ID, whether it's an integer or a hexadecimal number or whatever. And whenever you give me that integer back, I can basically run the reverse algorithm and give you the string. And so you just need to remember this little short ID, a URL shortener, and this service will like unhash it back, give you the original string, wouldn't send that out, and just return the website back to you. And same for generating like unique IDs. But I want to show you, because we talked about dictionaries. This is actually very valuable if you ever. It's just good to know a little bit deeper about dictionaries, because if you ever have to do programming interviews, in the real world job interviews, dictionaries are like always like guaranteed to be somehow one of your questions. And so just understanding just a little bit deeper on how dictionaries function will help you out, not only as a potential programmer, but if you ever hit these interviews. So in a dictionary, here's a simple Yeah, this one might be simple. So before we talk about buckets, let's just talk about yeah. So this is easy. This was more simple to approach. So in fact, this one's simple. So a dictionary is a set of keys mapped to values. Every element in the dictionary is a key value pair, one key to one value. And in some languages, they're handled differently, but in C#, you can specify whatever type of key type and value type. So here, but the simple version, we have a string as a key and an integer as a value. Although here um, they have like mixed values in here, but just assume it's just integers. I want a simple situation. So how does the key map to the value? Well, actually, it's being run through a hash function, and we get like a unique ID for each value. So you might like just say, hey, go give me the dictionary value at key name, and it'll just give you Anthony. But when you pass in that string, the hashing function will generate a unique ID that connects with this key to get to it. So this one gets a little bit more truer. So for each key, it'll get run through a hash function, and a unique location in memory will be connected with that. So it's really that like memory address will be remembered, and then the value is stored here. Here, this value would be a string too because it has dashes in it. It's like a telephone number. So the key is a string, the value is a string. But the key goes to a hashing function, and we get a unique ID, in that case, associating with a memory location that's the size of a string. And I liked, now this one's starting to talk about buckets. So we have keys that are getting hashed into locations in memory. Unique ID gets somehow it gets created from the string. And we have memory locations, but each memory location is a bucket. And it is saying a bucket because multiple entries can be used here. And this is where we can talk about conflicts, that eventually not everything will get a unique ID. There's many different types of algorithms for this type of like cryptography, this type of creating unique IDs. But they're not always guaranteed to give you unique IDs, so there might be multiple keys that are pointing to the same location. Here we've got a list of memory locations, and each key has a unique location and has one value. But the fact that they say bucket is useful because that's really what happening, is that you can have multiple entries. I think this one kind of... Let me see. This one's one. These arrows are kind of hard to follow. Okay. So this looks... My eyes are kind of bad. This looks like this one. And somebody... So this looks like Amit and Anu are pointing to the same memory address. Okay. So here we have like these buckets. But basically you could have like... It's really like keys, and then these might be like linked lists. Remember I covered linked like arrays and lists are just like they can point to another element. You can have like a list be as long as you want, right? So these actually memory locations are pointing to a start of lists, and if there's only one element there, it's just a list of one because there hasn't been a conflict there. But however, our hashing values worked. This Amit Sony and this Anu Kiran both went to the same address as 152, and so they do not have a unique ID. It's known as like a conflict, and so they're being mapped to the same ID, the same location, which it does happen, and that's why what these locations are pointing to are actually lists of types for values, because there could be multiple entries. So a mixed value is the first one in the list, and then a news is next here. So that's what these arrows are trying to indicate. So when there's a conflict, then you have to like move through each one, be like, wait, is your key this one or is your key this one, right? So for omit, you say, is this your key? Yep, okay, return this value back. And for a new, we have to like loop through all the list elements and say, are you matching this key? Nope, you're the wrong value. You, yep. So this does happen. And so dictionaries are not fail-proof. They can have this type of conflict, and then this is how it's resolved with it's actually mapping to lists. And most of the time these lists are the size of 1. All right. So anyway, that's hashing. That's your little intro to hashing. And that's it. So I think now we can look at, unless there's questions, we can look at the environment. So let's see, if we zoom out here, here we have, I'm just going to start clicking on the things most closest to it. So we have modular tracks, okay? So these are prefabs. If I open them up, it's a straight section. So here's the mesh, here's the renderer, here's the material, the collider, and underneath it is another mesh. It's just drawing that like lane divider in the middle. And so you can build these, one at a time. And you notice that it's important to see that their pivot point is like at one end of it, so they could be snapped together, and they could be like exactly placed together. They're not overlapping, or there's not gaps in between them. And then this must be a curved piece, and all the parts are the same except the mesh is curved. But notice the pivot is right at one end of it. And you can place it and rotate it, scale it, but I think for modular kits, you should stick away from that scaling it. I thought that was a pickup. It's just a post-processing volume. So here we have the start line, and it looks like it has a render, it's got a material, it's got a mesh, and it's got this box collider around it. And it's probably tagged with something. Nope, it's not. But it's a trigger. That's important. That you go through it. You don't like hit into it. And it has a little script on it. I'm gonna steer away from the scripts right now. I'm just gonna like start looking at stuff. But it's interesting to note that there's some processing done here. So this one's probably got a script on it too. These checkpoints. Let's see, it's got a collider at the top. It's a trigger. Pick up object script. And underneath it, okay, here's the mesh. Here's the mesh. Here's the renderer. Here's the material. And that's probably all the elements that probably have a script on it. But let me click on. So it looks like this is not modular. It looks like the ground plane is just a big circle. It has a render, so it does have a mesh collider, which is kind of expensive. I would have just done since it's just a big flat plane, I would have just done a big, like a plane collider, and cheaper than a box collider. And we have these little, so underneath stones here we have small and big stones. You could scale them. They're actually probably the same stone, just scaled and rotated asymmetrically. But it has a mesh render, no colliders. You're not supposed to touch them. Yeah, usually the big trick, like small stones and huge mountains, are the same thing usually, but they're just scaled differently. This horizon mountain is one big geometry. Okay, it's mesh. These things are just like circles. I thought they'd be spheres, but no, they're custom geo. But they're basically just smushed around spheres with the bottom part cut off. And here we got a tree, boxy looking tree. So somebody modeled it. It's custom mesh. And the round ones seem to have some children underneath them. So let's see what's going on with these. Yeah, it's just an empty root and the mesh is underneath it. Okay. Nothing special. Here, this part of the modular track is lifting up. So this is like one big piece. Okay, it's a spiral piece. So it takes care of the change in elevation. And these are just flat pieces. And then that one drops back down. Let's see what else. So I kind of talked about, we have a directional light source. And there's just like a plane with a texture for the sun. It rotates with the light. All right, we've got our clouds. Each one of these, notice they're grouped all together. It's easy. These clouds are probably just scaled and rotated. Yeah, they're all rotated facing toward world center so that they all look like full, nice volumetric clouds from the user's point of view. In other classes, I've taken this thing and like rotated it and rotated like the sun to have like a day changing and different weather and stuff. And then looks, we got a big skybox way out here. It took me a while to figure out where that thing was. I think it was under lighting or something. Main scene lighting. No, it was somewhere else. It was like a lighting window or something, right? Oh yeah, rendering lighting. The environment. Here's the skybox. It's this one here. Okay. And front, back, left, right, up. So it's just a big box and with textures being applied to each one. All right, and we got the big UI over here. And I think that's everything. And so let me just take a look at these little scripts here. And then we have to talk about what it might be done. We might be able to just do the quiz on Tuesday. But let's take a look. What's this thing? This big ring has got pickup object. Okay, spawn prefab pickup. So it'll drop a pickup if you run over this. Oh, VFX. Okay, it's like shooting fireworks or something. So, okay, interesting. It's inheriting from target objects. So you can take a look at that. So target objects inheriting from mono behavior. So the game mode, time gain. Let me take a look at this thing. What's being exposed here? Okay, game mode, gameplay, time. Yeah, all this stuff is coming from the base class. Time gain, what layer mask, what physics layer mask it's on, and what have you. So on enable. So remember, this is on awake, on enable. Is all the initialization. So this becomes true. Interesting. It's public, but you can hide it in inspector. So here's like something public, but you don't want it shown in the inspector. Okay, interesting. Protected void register. Okay, so protected is interesting. We've seen private and public. And public means any other object can call it. Private means only objects of the same class can call this, whether it's a method or referencing a parameter, property. And here we have protected, which means this class or any of its children classes can call this. So if this was like private, then its children classes wouldn't be able to call it or reference it. And protected means not only it, but its children can. And public means all. So register. So the objective on register pickup invoke. So what is the objective? The objective is another class. I was just seeing how is it referencing the objective? Maybe in pickup. Let me go back and look at your parent target object. So if anyone's listening to objective on register pickup, that's what that means, the question mark. Then we're going to invoke this. Okay, so an abstract class means like it cannot be implemented directly. Like you can't just make a target object. Only you can make it its children. So this pickup object can be created as a component object, and it's going to call register. I'll figure out what that objective is in a minute. But it calls register, which is coming from its parent class, but now it has on collect. So it looks like on trigger enter. When somebody comes in, and if it's the player, then we call on collect, play a sound, instantiate a VFX, destroy it, and unregister this from the objective. Okay, this must be like, okay. And then adjust time. So there's this time manager at the root, the game manager level. It's like managing time of the class. And then destroy this game object. Destroy this like ring because we just went through it. I think the objective then, oh, okay, I get it. This must have a static method then. Okay, here they are. Their events are static, meaning you don't need to grab the object. You don't need to grab an object of objective. You could just go right to the class. So that's what it's saying here. Like, go right to the class and unregister yourself from pickup. Okay. And so that's what your parent object was doing. Target object. So go to the objective class and call this static event. Call this event that's related to the class, not the object of objective. And you're saying, hey, unregister pickup, invoke it, and pass a reference to myself. Okay, so now we have a third class here, objective. And this thing, okay, these are how like the game objectives is being set up. So like must be up here. Game flow manager, the objective manager, audio manager, prefab replacer. Okay, so on Tuesday I'll go through this game manager stuff then. Cool. So the objective manager, I bet here has, yeah, you have a list of objectives. Yep. All right, this is opening up into a larger can of worms here. We got the game flow manager, and somehow objectives are being given. I think the objectives were, yeah, we have objective time limit. So we have an objective for the race here. and okay, game mode, these checkpoints. Okay, so this is a big one, the subjective time limit. So I'm gonna call it for today, and then we'll go through all this game manager stuff and these objectives, and that'll be the last thing that we're gonna cover. All right. Let me know if you have any questions. Otherwise, we have to go over game managers and objectives on Tuesday. All right, I'm going to stop the recording.